Okay, so in terms of interpretation, the odds ratio, we say if it is 0 point something, it is less likely. It is if it is 1 point something, we call that one as more likely. So you can actually say it is less likely by an odds ratio of it is less likely by an odds ratio of 1.77 relative to those that did not go for school significant at 1% or significant at 1%. Now, for those people with tertiary education, they are 25.1 more times more likely to watch TV compared to those who do not go to school, significant at 1%. That's actually the way we actually say. So again, on this one, I want you to go to check annotation for logistic, annotation for logit, annotation for that probit. Now let's look at combining these two. I can be able to combine the two models and create what is called a biprobit. Let's assume I don't want to waste much time and I want to compare the two. So you can just say biprobit. So our dependent variable is TWV, TVW, and the other one was the R list radio. Then I can say V0 I dot V025 and the V106 and the region, like this. So I have taken two models and put them together, and when I run, I can be able to come up with a full fitted model which has two connotations. Like in this case, you can actually see that it has given me, this one is a model for TV and this is a model for radio, but all of them, they are combined in one in one result. So this process is called bivariate, biprobit, where you are comparing two estimators and put them in one model. Now it is different from seemingly unrelated regression. It is different from seemingly unrelated regression, because if it was seemingly unrelated regression, then I would have had the two models represented in this particular part. Then I would have had the TVM and maybe put V025 here and open another one and say R list and put V106 here. You can actually see that in this case I am comparing two different things. Okay, TVM not found, TVM not found. Okay, yeah, it's TVW, like that. So in this case I have just put MV, which is a multivariate probit, and let's wait, it's taking some time to actually process so that we can be able to see what could be the result. So in this case we have got two models that are different that we are trying to estimate, but all of them, they are similar. Why are they similar? They are similar because this one is a binary and that one is again another binary, but we are estimating two different things in that. My computer is too slow these days, but it is coming. Let's hope it can converge, because it's like we are squeezing it to give us the result that we need. Let's hope it can converge. Okay, iterations, they have started. We've got 0, and let's hope it can give us the values that we need. Okay, yeah, it is taking time. You know, there are some models, they take time to run not that you have done something very wrong, but the Stata, it takes time to actually compute those particular variables. So it actually takes time to actually finish the iteration, because at this moment it's like I am estimating two different models, but that are the same, using the command mvprobit. So for you to use this particular command, mvprobit, in your laptop, you need to insert it. So you can just come here to say insert. Here you can just say insert mvprobit. Then it is going to give you a technique how you can be able to do that. Otherwise, you need to have a patch for that. So it has finished running. So you can actually see that it has given me two different results. So this is actually this model, it is only estimating place of residence, whereby this model, it is only pressing education. Therefore, you can now start concluding and make inferences from that particular point. Okay, so the question that one can ask is, this type of model where I've got V025 without looking at the factors inside, it is not a good one, because you can actually make a wrong conclusion at this point. But when you are looking at things inside, you can now look at the effect of each component inside and make policies that are directed. Like at this point, you can just say education has a positive increase, has a positive influence of 0.34 unit, etc., meaning that a relative change in education, people are actually listening to radio by a factor of 0.33, significant at 1%. Now that cannot be meaningful, because which education level is it? So if you want to consider education levels, then you actually use the i.dot command to do that. Now another thing that we need to look at is having done the, let me come back here, having done this type of a model, okay, having done this type of a model, okay, sometimes you can actually do the marginal effects. I mean, not marginal effect, yeah, the marginal effect, because in economics we prefer people using marginal effects. So the command you do that is you do marginal effect, you predict the probability of the outcome, which is equal to p, the first model, it must be 1 when the first model is equal to 0. So when you do this and then you enter, it is going to give you the marginal effect when p is equal to that. Let me see, why is it rejecting? Okay, let me just go straight in this part. Let me remove everything by just putting the PR here, probability, and remove this. This should be able to work. It's taking time, but it is going to work. So let's see what is going to be. So it is processing. You actually see it here that the value is being processed, and this is actually what is called a permutable processes, or a permutation, where you actually can be able to do a twist of so many things so that you can actually have what you want. So it is actually regarded as a permutable process. So like when it is P10, I can put P00, I can put P01, I can put P11. So 1 means in probability in equation 1, which is this equation, when it is equal to 1, and the relative to equation 2 when it is equal to 0. So it is considering that, what if these ones are 1s, these ones are all 0s? What could be the margins? And sometimes you can come back, I don't know, it is taking time, maybe it will come out. Now what about when this one is equal to 1 and this one is equal to 0, it calculates. And what about when this is equal to 1 and this is equal to 1, it calculates. What about when this is equal to 0 and this is equal to 0? So you can actually see, so it has calculated the margins at this moment, when TVW is equal to 1, listening is equal to 0. So it has predicted P1 is 0. So you can actually do the same. Just copy this command like that, okay, like here, and then you change whether this is 1 1, and then 0 1, and then 0 0. You can actually now look at that. So I want you to understand as to why do we do that particular shift. So it depends on your hypothesis. Do you want to calculate margins when people they are not doing well? Then you actually predict like this. When people are doing well in all cases, then you can actually have 1 1 like that. When people are only doing well on one side, then you can actually have like this. Or when people are doing well on the other side, you can actually have something like that. So this is actually the way we actually work on the margins. So we have discussed quite a number of issues at this particular point. We have discussed the probit, logit, logistic, bivariate probit, multivariate probit, and how to do the margins at the same time, marginal effects. So what I want you to do is I will give you this particular data set, and I want you to actually have the assignment, a very big one, which I'm gonna write what you should do using this particular data, and you should be able to actually come up with the interpretation and the connotation on this particular part. We should be able to have a very good run, but for the time being, this is actually how we can summarize the marginal effects. So I will give you everything that you should do, and the next topic we are going to look at the multinomial decisions, and under multinomial we'll look at the ordered logit and ordered logit and the multinomial and their respective decisions, and then we'll look at the Poisson decisions, stroke Tobit decisions, and then lastly we are going to look at the PSM. So we need to finish up within a short period of time. Thank you.